Hello, this is the Junkyard Messiah with RadarDetectorForum.org, and today we're going to be talking about LiDAR jammers, namely smart jammers, and actually explain how they work. I think first, however, we will probably touch on the base of what is LiDAR and how that works before we get into exactly how the jammers work. Again, we're going to be talking about smart jammers today, not brute force or other types of jammers. But most of the jammers that are on the market nowadays are smart jammers, namely 99% of them. So just a moment here, we're going to go ahead and talk about LiDAR and how it all works. Okay, welcome. What we're going to talk about today here is how LiDAR works first, and then we're going to talk about how a LiDAR jammer successfully jams LiDAR. The first thing to understand is that there's a constant in the universe, which is 186,000 miles per second. That, ladies and gentlemen, is the speed of light. That is a constant in our universe. It is something that physicists use every day. This number is pretty much infallible unless you really do some really wacky stuff, like bend it using gravity and, well, bending time-space. But it's 186,000 miles per second. That's the speed of light. We know this. It is written as part of our universe. It is a fact. And it's because we know this number that it allows us to be able to do calculations with something called a LiDAR gun and basically do distance measurements, which is also part of what LiDAR does. Because I can take a pulse of light and fire it at a wall using a LiDAR gun. Bounce it off of that wall and get the return signal to my sensor on the gun. The time it takes from it to leave the aperture of the gun, bounce off the wall, and return gives me distance. I know exactly how far, down to millimeters, this wall is from me. Well, great. I can now tell the distance of something. How does a LiDAR actually get speed? Well, it's actually quite simple. Unlike radar that uses something called Doppler shift to be able to determine speed by change in frequency, LiDAR does something completely different, which is when you're heading down the road in your car and Mr. Police Officer pulls out his LiDAR gun and shoots you, that reflected pulse is going to come back to his gun. It's going to tell him the distance of your vehicle at that time. We're just going to say 1,200 feet at this point. Okay, so you've moved from here, and again in time ticks, from here to here in 2.5, 3 seconds to 600 feet. Again, the gun firing at your car reads the speed by determining the distance change. In other words, the time it took you to go from 1,200 feet to 600 feet is your speed. It simply works out as time over distance equals speed. He knows how fast you're going because of how long it took you to change the distance to the gun. That's how LiDAR works. So what we're going to do next is we're going to talk about, well, how does the LiDAR jammer beat it? How does a smart jammer do its thing? Well, there's a big reason why I'm doing this video, and the main reason I'm doing this video is because I had a bit of an argument with another gentleman on another forum who was completely convinced that he had a miracle of a jammer. I call it a miracle of a jammer because I think, quite sadly, he ended up listening to the sales guy instead of people who are a little bit more versed in this, and he was convinced that the jammers that he bought had an unusual capacity, and that was to be able to actually bend the light around his car, that his shifters would be able to shift the infrared pulses from Lidar around his vehicle. This is not how Lidar works, people, or jammers work, excuse me, because if he could do this, then unless he bought his jammers from Area 51 or us, or is part of some alien space program where he can bend space-time, no, this is not what's happening. You cannot bend the light waves around your car. If he could do that, he could make his car invisible if he wanted. This is not how Lidar jammers work. So what I'm going to do here is explain exactly how Lidar jammers do work. They do something pretty cool, and I would say that is rather creative when the engineers came up with this. And what Lidar jammers do is effectively predict the future. You'll understand what I'm going to say here next. Let's talk about the Lidar jammer first, just for 1 second. Lidar jammers have a microprocessor in them. Those microprocessors are relatively cheap in that they're $3 to $5 a piece, but they do an amazing 800 MIPS. That's millions of instruction processes per second. Okay? That is really freaking amazing, especially at the price that they do. That means that it can do 800 million instructions per second. It's fascinating. Now, you get two types of Lidar jammers. You get the Lidar jammers that are the processors actually built into the head. And they have LEDs, or maybe a single laser diode, and they all have some sort of pickup, namely photodiodes. And everything that's done is done in the head. And then you have the type that have an external CPU, still has the same sort of processor in it, and it simply uses the head as the dumb head through wiring. So the Lidar that comes to the head, it communicates to the CPU communicates back, and fires the LEDs or fires the laser. It's all very, very basic. But they all have a CPU. All the smart jammers have CPUs. Okay. So now you're wondering, all right, get to the point. How does a Lidar jammer work? We'll try and understand. I'm going to try and do this in steps so you can understand the format behind this, so this actually makes sense. So we have our timeline, and we have a Lidar gun from the police firing pulses of infrared light at your car to determine your speed. Well, these pulses, in most cases, not all, but in most cases, come in regular intervals. And because they come in regular intervals, we can determine something called the period, which is, this is the spacing between each one of these. Knowing what these spaces are allows us to do a lot of different things. If this was a typical gun that was doing 200 pulses per second, we can actually resolve the period, which is, here's the on time when the laser is on, and the off time when the laser is off. Okay? Now this would be a 50% duty cycle. Is actually what it should look like is some very short period, because the period, the pulse width of these pulses is only 50 nanoseconds. Remember that the speed of light is 186,000 miles per second. 1 nanosecond is only, again, the speed of light being 186,000 miles per second, give you an idea how short a period a nanosecond is. Light only travels 11.8 inches in 1 nanosecond. Light's fast, but the time division of 1 nanosecond for the speed of light means it only gets to travel 11.8 inches. Neat stuff. So the pulse width, the duration that the laser is actually on, is extremely small. This allows them to pump a lot of power out for an extremely short period of time and still fall under Class 1 certification, or eye safe. They're not allowed to fire lasers at your eyes that can do damage. So they have to be extremely powerful for extremely short periods of time so they can get enough energy back so they can read your speed. Because this energy they're going to get back is going to be in the microjoules and picojoules. It's going to be tiny amounts of energy that are being reflected off of your car, especially at distance, to be able to determine your distance over time to get your speed. Well, we can resolve what our period is, which means 200 pulses per second. That's what the Lidar gun is putting out. Resolve that as 1 second is 1,000 milliseconds. Well, it's pretty easy to figure this out. 200 pulses per second, 1,000 milliseconds. How many times does 200 go into 1,000? That's right, 5. And that means that the time, the period, for when the laser is on and when the laser is off is 5 milliseconds. 5 milliseconds, 5 milliseconds, 5 milliseconds, 5 milliseconds. I can expect a pulse, a pulse, a pulse, a pulse, a pulse. There we are. So we understand that now. Well, the CPU in your jammer understands that as well, and this is how it can predict the future and be able to jam the Lidar gun. And I'm going to show that here. It's very simple stuff. All right. So you have your jammer head with its CPU. I'm going to do another timeline here. And in red, we're going to show the pulses coming from the Lidar gun. And what we're going to show next is the reflected pulse. This is the pulse that has been reflected off the bumper and has reported back to the Lidar gun. Okay? This would be what would determine your speed over time, because it can actually calculate the distance on the constant of the speed of light. Well, the CPU is fairly smart, and if it's well programmed, it's even smarter. It sees these pulses coming to its little photodiodes. Bang, bang, bang. It has already determined that these are all 5 milliseconds apart. Okay? Well, if I see bang, 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 where would I expect to see another one? Another 5 milliseconds. Another 5 milliseconds. So I can now determine when the next pulse is coming up. I can predict the future. I can predict what is going to happen next. And this gives the process the ability to be able to introduce its own pulse, which means that it always has to try and beat this return, this reflected pulse. You have to beat this reflected pulse on a regular basis, unless you try to incorporate it into it. We're talking about that later. You have to beat that reflected pulse every time. But since it can predict the future, as long as it can see the pulses, it can preemptively, oh, I see this pulse. I saw a pulse previous to this. I can inject my own pulse in there. I've seen the pulse previous to this. I can inject my own pulse. And so on. So it can see whatever it sees before, allows it to produce a pulse preemptively to the return pulse that would be reflected off your car. Well, if this was all that was happening, this would be the end of the story, and yay, this is how jammers work. No. It goes a little bit crazier than this, and I'll explain why. If the jammer was simply throwing in a pulse before the reflected pulse got to your car, then this is now being seen as its own pulse. It's accepting this pulse as its own pulse, and it was always in the same place, then, Well, you would have the perfect Lidar mirror. It would be able to instantly get your speed because you're throwing out all this radiation on regular intervals. You're just injected the pulse at the regular intervals. No, that is not what happens. What happens is actually kind of neat. There's a lot of different ways that it can happen, but it's all about the same. All right. So we have our jammer. Let's try that again. We have our jammer head with our CPU. We have our timeline, and now we're going to zoom in. We're going to zoom in a lot. There's our pulse. We've predicted this pulse. This pulse exists to us. We know it's coming. We saw it in the crystal ball because we've seen all the pulses up to it, and we go, there that sucker is. Here is the pulse that would be reflected back. This is the pulse that we want to beat. This is the pulse that reports back to the gun and gives you the distance. All right. So I, as this little Lidar jammer, throw out a pulse because I predicted this one. Okay? I have thrown in a big fat pulse. Now the Lidar jammer is going to see this because it's the first thing up because it was preempted that reflected pulse. There it is. And it's sitting on a timeline. Okay? I moved it up. Instead of reflected pulse being back here in the timeline, it's here in the timeline now. Great. Well, the next thing it does is that it predicts the next pulse. I see this coming. I see it coming. But instead of putting the next pulse in the exact same spot, it puts it here. And the next one after that, it puts it back here. Predicts, fires a pulse. Predicts, fires a pulse. Next one, it throws it in here. Well, what does this mean? Well, remember that the Lidar gun determines speed by distance. This is a timeline. If I shift the pulse, if I keep shifting the pulse that the gun is accepting in time, I'm actually making the gun believe, or I'm confusing the gun in so much that your car is moving back and forth in space. In other words, pulse. Here's the pulse I generated, 2. Your car looks like it's at 2,000 feet. Pulse. Your car has just moved up to 50 feet. Pulse. Your car is back to 1,000 feet. And it does this. It shifts. Remember the word shifter? It shifts the pulses that it generates in time, always beating this reflected pulse. So the jammer sees the vehicle moving in space. It cannot get a speed because it cannot get enough pulses back, and is required by a Lidar jammer because it's required by law to be an accurate device that it needs so many pulses back to be able to read the speed. They have to be consistent. Well, this just throws all that out the window. This is the blender of pulses in time where the vehicle looks like it's moving back and forth through space. So it can't get enough synchronized moving from 2,000 to 1,000 to 500. No, according to the gun, your car is doing 50 feet, then going to 2,000 feet, coming back to 1,000 feet, 50 feet. That's the basis for how Lidar jammers actually work. Now, there's nothing that says that a manufacturer only has to throw in one pulse in that timeline. He could throw in a pair of pulses just to make sure that I beat this one. Even if it doesn't see this one, it'll see this one, okay? And then the next time around, it'll throw out, again, it's predicted this pulse coming up, another pair of pulses, completely differently timed from the first pair. So it'll either see this one and this one, or just see this, except this is this one, it gets to us this one, and it beats this one every time. You could do a lot of different things with it. You could the rate of the pulses, how close they're together. Since I can predict what the next pulse is going to be, I can preemptively generate a pulse before this reflected pulse ever has a chance to reach the LiDAR gun. And I think that there probably should be a standard set. You might want to call it the pulse timing quality or something along that lines of different jammers, because different jammers do some of the same things. I don't know if they can possibly patent a pulse group that is shifting back and forth. Like, one company does 2 or 3, and then 3, 3, 3, 3, or something along that lines. But the fact of the matter is, how you do this is well documented and tested by the LiDAR manufacturers. And that's also why they run updates a lot of times, that because there are new guns that come out, or guns that try to adapt to LiDAR jammers in some cases, that they need to come out with a new way of sensing and jamming that gun. So those pulse groups will continuously change and evolve as new guns come out. But that's all there is to it. You basically just have a system that is being able to predict the future by determining the period of evenly spaced pulses. There's other ways to do this as well, with pulses that are hidden amongst lots of little pulses. That has to do with the fact that the jammer is able to determine that this is a 50 nanosecond pulse and these are 10 nanosecond pulses. Okay? And because of the fact that I'm looking for something that's a wider pulse than this, I can pick that period out from the rest of those pulses. But that's all that happens. It's predictive on what's going to come up next. What is the next? What am I expecting to see next? And it can preempt. I really think that's it. I think that pretty much covers most of it. If you have any other questions, please be happy to log on to radardetectorforum.org, and I'm on there quite a bit of time. And if you have any other questions as to how LiDAR jammers work, or how LiDAR works in general, or even how radar works, I'll be more than happy to help you. Have a nice day, and this is the Junkyard Messiah.